Right guys, we're going to have a look at making up some extra change gears that I don't have with this set. One of the things you do get, I guess, when you buy second-hand lathes, if they require change gears, those sets are often missing, or the only sets you've got are the actual ones that are actually on the quadrant plate and drivetrain. So these are the change gear sets down through here. So they allow you to cut imperial or metric just by swapping these two around. So they're your 127 and 120 tooth gears, and you've got a series of gears that go in between to be able to match up the TPI or the feeds and speeds that you want to run your carriage at. So I'm missing 4 out of my set. So I'm missing the 25, I'm missing the 35, I'm missing the 50, and I'm missing the 55. So I've gone ahead and just done some quick numbers on this. The module, or the way the module works out, as best as I can calculate it out, is 1.75. So there are a metric set of gears in this. So I've just done the ODs for each one and what the pitch diameter is going to be, and tooth depth is 3.8 millimeters. We have a bore that we need to put in at 20.04 with a 6mm key. So they're the parameters we're working to. Okay, and to be able to cut the gears, we need to get some gear cutters. And I call this the Brown and Sharp system. I think that was where it was originally developed. So I bought these off AliExpress, and I got these for, I think it was around $89 Australian delivered, which was really cheap. That was the, they ranged up to closer to $300, just over $300 for a set, but to get them for around $89 delivered, I was very happy with that. And there's a set of 8 in here, and they will range from cutting a rack all the way up to, I guess, an infinite number of teeth with everything in between. So I've got the gear cutters. The next thing we need to get is our stock. So let's just go and have a look at bits and pieces that I found in my scrap bin. Alright, for the 25 tooth I want to use some brass, and I think I've got just about enough stock on this to be able to make this gear up. I think that drill end there that's in there, that's 120 degree drill end, I think that'll just clean out if we take the minimum out off the back. So guys, important, don't chuck little bits away, you never know when you might use them. So the 25 tooth one is the one that's predominantly used as the main input, or the primary input. Right, for the 35 tooth, I'm going to use this bit of stock here, so I can get an end off that. So that ends up with an OD of around about 65mm. So I can use that bit of stock there. And for the 50 and 55, I need 91mm OD and just shy of 100mm OD. So I've got this bit of stock here that I can use. So I use the smaller lathe to do the small gear, and then we'll use the big lathe to cut its own change gears. Alright, let's get a start and we'll see how we go. Well, before I do forget, yeah, it's a 20mm bore that I've got to put in this with a 6mm keyway, and I've got a broaching set for 6mm, so we'll just broach those the keys in much quicker and easier. Well, we're going to cut the 25 tooth gear first. It has an OD of 47.25. and the overall width is 12mm. So what I'm going to do is face it, and I'm going to bore it. Once I've bored it, I'm going to make up a mandrel to sit this on, and then face it again, and then turn the OD. So the OD is going to be dead plumb to the bore. Pilot on here. I'm sure you're all aware of what brass is like to machine with a sharp drill. I should really blunt this off, but it will tend to try and draw it in. So if you put a pilot through, it tends to grab an awful lot more, whereas if you're drilling it blind, you tend to have better control over it. Righto, we're aiming for 20.05. 20.04, sorry. That's bang on the money. Right, we'll get the other blanks made up in the other lathe and get this mandrel made up and get things mounted. Alright, those amongst you who are fairly astute would notice that we no longer have the same stocking. It just wasn't going to clean up and give me the bore that I needed. It was going to be oversized with that hole that was already pre-drilled into it. So I've got this bit of stuff here. It's 70mm, we're going to take about 5mm off the, or 6mm off the OD and get it down to size. Now, I can't really use the feeds on this because the gearing I've got on this is totally up the creek. It's very, very coarse until I get this 25 tooth gear in place. I'm just going to have to hand feed stuff. 20.02. I think we'll leave it at that. I'll just give that a little bit of a lineage out. It's got the OD to size. But yeah, the Digirita, it's pretty right, 0.01 left to go. Widen that 0.01, just give it a lineage and get it to size. It's pretty horrible stuff, this steel. It's got little tears on it, so I think we'll just give it a lineage to take off that last little tiny bit, and then we'll part him off. Right, we're going to do the larger gear first, which is 99.75mm in diameter, and I'll see how I go with this parting off through this thickness here. It might be a bit of a struggle, but we'll give it a go. It's a tad over 100 mils, so we've got about 0.2, just over 0.25 to take off. It should clean up okay. I'll do the drilling and the boring. I'll machine the size and then we'll try parting off. Okay, that's it parted off, and it was rock solid through that, so very happy. Quite a bit of blade stick out too, but had absolutely no vibration while I was doing this. One thing I'll point out to you is I'm pretty sure this is a 4140, it's a high tensile steel, and it was fairly hard to cut through. Probably not going to be the ideal stuff to make gears out of, but anyway, it's the only stock I had. It did get rather softer towards the middle, and that's what you'll find with high tensile bar stock. They will only guarantee the properties, and this might be around a 900, 950 meg material. They will only guarantee that property for a certain thickness, and after that it gets back to no more than a 1040 steel. And that's why it's important, if you are machining a lot of this material away, be aware that you're also machining away those properties. And in some cases it's important to go and have a heat treatment done just to bring those properties back up before you do the final machining to get that tensile strength back into the material. Right guys, I'm not going to use that bit of high tensile bar for the 50 tooth gear. I've got a bit of slug stock that's when I go down to my local steel supply, he has a lot of this stuff sitting on the shelf and he sells it at scrap value. So I'm down there, I can get my hands on a bit of this stuff. I usually buy about 20 kilo of this stuff, but it's really handy for small jobs. Little jobs like this. I'll see how that larger gear goes, the 55 tooth ones with that high tensile material with the gear cutters. It looks like it's going to be too hard. I've got another bit of stock there that I'll use to make up another blank. Alright, so I won't show this one on camera. You've seen it being machined and bored 3 times already, so we'll come back when we've got this one knocked over. Right guys, I'm going to set this up in my broaching press and cut this keyway in. It's a 6mm keyway. I won't take you over there because I've got it sort of jammed in the corner with all sorts of stuff around it. I haven't got it set up properly, so I'll go and broach these in now and we'll come back and see how it's turned out. Well, I've just made up a simple mandrel to turn the final OD for this 25 tooth gear, and I'm going to use this mandrel too to set up in the dividing head in the milling machine to cut the teeth on all the gear sets. And stepping back, this is my dividing. It's a fairly old dividing head. This one I got it from a good mate of mine, Les, who gave it to me as a gift. So I know Les, you watch my channel. Thank you very much, Les. It does get some use. And as I said, I have converted to a stepper drive, and we're working through the electronic unit. So I built this back in early 2000. A guy called Steve Ward on CNC Zone put hex code in to burn the chip with a circuit diagram. Created our own circuit diagrams, and we made up a couple of these, me and a couple of mates, and less than $100. The keypad you can see there is just a bit of A4 laminated and stuck on. Works quite well, and as you can see, I've got the division set up there ready to go at 25. Right, what I'm going to do first is I'm just going to do a touch off, rotate, touch off, rotate, touch off, just to make sure that everything does come out even Stevens on this. So I'll do that off camera. Let's come back and see how it looks when I've done that. Alright guys, as you can probably see, I've cut the brass gear, the 25 tooth brass gear. My camera ran out of battery, so I couldn't show the cutting of this one. I'll show the 35 tooth one, a little bit of that as we go through with the electronic indexer for the dividing head. I've run this and it runs beautifully, no issues at all. Just put the smallest amount of backlash in there and it's gone like a treat. But I have another bigger problem, and I thought I had to make up 4 gears. Well, I don't have to make up 4 gears, I've got to make up 5. And the biggest issue I've got is that the 2 gears here are supposed to be a 120 and a 127. 120 for cutting the metric, and then the 127 conversion for doing imperial threads. That one there I should say that one there is 105, that one there is 120. So I've now got to make a 127 tooth gear to be able to cut imperial threads. So that's going to be, yeah, I've got to find a bit of plate, get that gas axe to diameter, and set that up to cut that. Now I have looked around the net to see if I can find there one who sells a 127 1.75 module gear. This is a half inch, or I should say 12mm blank on this, and the only one I can find is out of Germany, and he won't post to Australia, and that was going to cost me around about Australian dollars, about 500 Australian dollars plus postage. So I think I'm going to be making one, which is not what I was hoping to have to do. But anyway, we'll get these other three finished, and then we'll focus on what we're going to do with this 127 tooth gear. Well, let's head back over to the mill now. We're going to start cutting the steel gears. As I said, the first one we're going to be cutting there is the 35 tooth. So the configuration I have here at the moment, I can, once I get the smaller gears cut, I can cut metric. I can cut all metric, all the metric threads, but obviously, as I said, I just can't cut any imperial. All right, let's head over to the milling machine, and we'll have a look at the setup we've got for the 35 tooth. All right, so I've touched off on the top of the blank, half the blank diameter. Measured the thickness of the gear. It's a different one than the 25 tooth one. Half the distance, and subtracted it from half the diameter of the blank, and that's given me my center position. So I'm just going to touch off first, and we'll get that zeroed, and then I'll go over to the electronic box, and we'll program in the 35 tooth. Okay, that's zeroed off. Okay, on this unit we've got various functions. We can jog, we can program by degrees. There's a program setup we can do there. We can program by divisions. We can make it run continuously, and there's a separate setup function there as well. We can run up to, I think it's 5 different ratio sets. So if you've got a dividing head at 90 to 1, and you've got a rotary table at 45 to 1, we can set them all up individually and just set up the particular, or just select the particular program that we want to run. But we're going divisions, so we're going to select 2, and we're going to put in 35 tooth. And we're going to enter that. All right, so we're ready to go. A little bit of vibration there. Let's have a look at what the finish is like. It's got a lovely finish on it. Alright, I might play around with the depth. I might do this in 2 passes. We'll just see how we're travelling. I don't like this arbor. This is a real cheapie I got from eBay. Not a good register onto the cutter itself. I'm still waiting for the ones that I ordered through AliExpress, and they've been over 2 months now. Proper arbor with spaces, but I'll persevere with this one while I can, and I'll see how we go. Anyway, look, we'll bring you back when we're almost at the end and see how we're travelling. Let's do one more index. Alright, so we're nearly there. And a few more teeth to go. Righto, index for the final cut. So there we go, hopefully. Alright, let's get it out and we'll see how we did. Oops. Give that one a bit of a tap, it's just a little bit firm on there. It's the key that I'm using. Get that out. Sorry, little bloke. He just sits in a little keyway back here, like so. Alright, well, I'll get this cleaned up, get it deburred, and let's have a good look at it, eh? But first impressions are it's absolutely spot on. But let's get it cleaned up and confirm that. Okay, that's our gear, and I've had a good look over that, and well, as far as I can tell, it's perfect. So I've just got a chamfer off each of the teeth, just put a little chamfer on the teeth, but I've deburred it. And yeah, spot on. Alright guys, I'll get that very tedious job of chamfering each of those teeth out of the way, and I'll set up for the next blank. Alright guys, now that I'm getting into the larger diameter gear teeth, or gears I should say, I'm able to get a stop in. Now the smaller ones I wasn't able to do that. I'm able to get a stop in now where I can cut the opposite direction into the stop. This is just an angle plate that I've bolted down to the table. I've just got a stud of my clamping set, which I've bolted into place, or locked into place with 2 nuts. And I've got a nut here that I can back off, like so. That removes the tension. I'm going to index the dividing head. Lock it off. Bring the nut up. And put a small amount of tension on it. And with this arrangement now, there's very little vibration. I'm just going to show you, I'll cut one tooth just to show you how much more stable this arrangement is. And obviously with a larger gear, and as I mentioned before, the 127 tooth I've got to cut, I'm going to set that up in an entirely different arrangement than this. So have a look out for that anyway when we get there. Alright, I'm going to get this on the go, and we'll cut another tooth. I'll get you nice and close. So as you can see in here, that is just so much better. No vibration at all. Alright, this is a 50 tooth gear, this one, and I've still got the 55 to go after this one. So I'll get this one completed out. I'll have the same setup as this for that 55 tooth gear, and we'll come back when we've got them all cut. Alright, that's all our gears completed. So I'm very happy with the way they have come up. So that's our 55, our 50, 35, and our 25. So they do run together very nicely, so very happy with that result. Right, let's turn our focus to doing the 127 tooth gear. As I said, I have a bit of stock. I'll show you that now that we're going to be using for that. Now, as I mentioned, when I'm down at my steel supplies, he gets all sorts of oxy-cut bits of plate, different types and different shapes and different thicknesses. So this is a bit of stuff that I got. It's a bit of hexagon stuff. It's 16mm thick, and between where the cut finishes and the bottom, I've got about 5mm I can clean up if I create a circle out of that. So I'm going to mark that up, cut it roughly to shape on the bandsaw, and we'll start cleaning it up in the lathe. Alright, so that'll be the next task. Alright guys, we'll see you when we kick that one off.